Well, thank you all for having me. My name is Charlie, as Diva mentioned. For those of you who have never really worked with SQL before and have never really written code, and you're not very computer sciencey, and maybe this subject matter looks kind of intimidating, I just want to encourage you that you are in the right place. We are going to start from absolute zero and build up from there to the point where you're able to write some just very basic SQL queries on your own. This subject matter is not super difficult. I myself have absolutely no background in computer science at all. So I currently work for a company that makes data analysis products for the Department of Justice. I spend the majority of my day working in the money laundering and asset recovery section. But before that, I was actually a crime analyst. I started off at the city of Cincinnati. I went to the city of Wichita. And then since leaving the public sector, I've stayed engaged through a couple of different grant programs. So I work for the Crime Analyst in Residence program, as well as Project Safe Neighborhoods. And both of those grant programs provide training and technical assistance to police departments all across the country. So I've probably at this point in my career walked into maybe close to 50 different police departments and stood up analytics. I've worked with analysts that have come from a wide range of technical background. And if you don't know much about SQL or you struggle with SQL, I can tell you that you're in a really good company in this space. And so I have a ton of experience working with police departments, extracting out NIBRS data and setting up automated analytics. And hopefully after this session and next week's session, you've got enough knowledge that you can begin putting some of that stuff together as well. I do want to give credit where credit is due. My partner, Amanda Bruner, did help me put this presentation together. She's also running for president of the International Association of Crime Analysts. So if anybody's a member of IACA and you're asking yourself who's a good candidate to vote for, my strong encouragement would be to go over to their website and vote for me. All right, so why do we learn SQL? The reason that we learn SQL is that there's two ways to interact with police department data. It's almost always going to be structured in what we call a relational database, and that relational database is going to take the form of a records management system, RMS. Sometimes some police departments refer to it as a case management system. It's ultimately the same thing. So the first way to work with RMS or case management systems is through the front end, and that's where you log in with your username and password, and there are these little forms where you can type information in. And just for some point of reference about how much more efficient working with the back end of that database can be, whenever I started with the city of Cincinnati, we had a team of 5 police officers, and it was their job every week to put together our weekly comp stat presentation. And so they would basically be in charge of breaking down crime patterns and trends into 7 and 28, 90-day, year-to-date categories and look to see what's going up and what's going down. And they spent 40 hours a week putting this weekly meeting together. And it took them so much time, it took them so much effort because they were using the front end. So they would go, on Monday they'd come in and they'd go to the front end and they'd say, okay, we need a count of how many robberies occurred in the past 7 days. And so they would go to their little search box and they would type in robberies and they would type in last 7 days and they'd press a button and then they'd count how many rows came up and they'd say, okay, 13 robberies in the past 7 days. And then one guy would yell 13, and then a second guy would type the number 13 into a spreadsheet. And then they would do the same thing for 28 days. And then they would do the same thing for 90 days. And then they would do the same thing for large space and auto thefts. And they would manually assemble these counts. And in a very short time period, we had taken those 5 officers and completely put them back on the road because we were able to create SQL queries that would extract out all of the data that we need and put it into visualization tools for us automatically. We used Excel a lot, we used paginated reports a lot, we used Power BI a lot. But before it could go to any of those visualization tools for getting counts and getting patterns and getting trends, a SQL query had to run. And it pulls all the data out of the back end and it shoots it into a visualization where all of those counts and stuff can then be automated. And so I'll talk a little bit about some of those workflows a little bit later. But essentially, we got that 40 hours a week that those 5 guys were putting in down to just one button click. It was a macro inside Microsoft Access. And we'll talk about how to build those today. That they clicked, it would run all the queries that we needed. It would shoot out all the data to all the different places that we needed it to go. And then we would open up those different visualization tools and bam, everything was calculated for us. This is an example of a fully automated product that I created for the Pennsylvania County, Virginia Sheriff's Office, just using Microsoft Excel. And so they open up their Excel workbook every day, they click refresh. There's queries that have already run automatically in the beginning of the day. So those queries go extract all of the data out of their RMS and leave it on their desktop. So whenever the analyst wants to come in and see how have these patterns and trends changed, all they do is open up their Excel, they hit the refresh button, it goes and gets all that new data that's already been extracted via SQL, and then all of these numbers are calculated using formulas. All of the formulas update to reflect the new data, and then they've got all of their patterns and trends. This is another product that looks a little bit more, I'll call it CompStat-y. Anyone who's ever been to a police department CompStat meeting knows you typically see these big tables full of counts and percent changes and things like that. Same concept. It's built in Excel. When the analyst comes in, SQL queries have already run themselves at the beginning of the day, and we'll talk about how to schedule those SQL queries to run. They just open up their Excel book, they hit refresh, and all of these counts and stuff, all of them automatically update. Okay, so before we can actually start talking about SQL, we have to talk about the back end of these databases and what that kind of looks like and what all is there. And I find it helpful to define a few key terms. Anyone who's worked in a police department for any period of time has probably heard all sorts of things described as a database. I tell the story of the time that I got called into the vice office because they wanted to discuss sharing their database of human trafficking suspects. And after a lot of back and forth between them, they finally, quote unquote, gave me access, and it was a PowerPoint. I'm sure that all of you guys probably have a story where somebody says, here's a database, and they hand you a Word document or something like that. In a much more formal sense, a database is basically a collection of tables that may or may not relate to each other. They may or may not connect. And we'll talk about what those relations here mean in just a minute. A table is just rows and columns of data. You can think of it like a spreadsheet, and a database is a collection of a whole bunch of them. Queries are what we write in SQL, and SQL queries run to query out that data. Sometimes we can pull out entire tables. You can also just pull out certain columns of a table or certain rows of a table as well. Forms are ways of doing data entry. So if you think about the police officer sitting in their cruiser and they've got like their laptop up and they're typing information into boxes as they fill out a report, those boxes are all just one big form. And then reports are analytical products that analyze the data that is stored inside database tables. So we have to talk about what a relational database is and why we have to use them. But for beginners, I like to use the example of the police chief who decides that he's going to replace his entire RMS with just one big spreadsheet. I call this the spreadsheet problem. And I've never actually known anybody who's done this. I've heard of this happening before, but it certainly seems like the sort of thing that some police departments I've worked with in the past might actually try to do. Let's just, our RMS is a pain in the butt. Why don't we just have one big Excel sheet? Well, the answer to that is that it's going to be really difficult to maintain any sort of structure of that Excel sheet. Let me show you what I mean. So let's just say we do this. Let's just say we don't need a relational database. We're just going to keep one big spreadsheet. And lo and behold, we get a murder. Okay, so we're going to go over to our Excel sheet and we're going to type some things in, like incident number, suspect, the date it occurred, the location, the reporting officer. So far, so good, right? This actually looks like it could be a suitable replacement for an RMS. But now what if we have 4 suspects? Well, this gets a little bit more complicated, and then those 4 suspects might also be connected to a whole bunch of different homicides. What would we have to do to structure one spreadsheet to contain all this information? Well, we could start by building a spreadsheet like this. Just like you saw before, we're going to put all the things in there that there can only be one of per report, like report number, date, time, location. But then we'd also have to put some columns in there to contain however many offenses there were in each report. And how many offenses can there be per report? Well, there can be a lot. Let's just put 4. But what happens if we get a 5th one? And how many suspects can we have? Well, or I guess we'll put 4 suspect columns there too, but we could have 5 suspects. And then what do we do if we want to query all of the offenses in this data? What column do we look at? We have to look at multiple different columns. So instead of doing it that way, instead of constantly going in and adding additional columns to facilitate additional offenses, or instead of having to count 4 or 5 columns to see how many different offenses have occurred, we'll typically set up our relational database like this. Everything that can only occur once in that incident will be kept in its own table. Like that first table we saw where we were just writing incident number, responding officer, location, date. There can really only be one date occurred for every incident. There really can only be one primary officer, right? That's all good. All the stuff that there can be multiple of, like offenses, suspects, things like that, we'll contain that in a different table altogether. And so our offense data won't be structured in columns like that spreadsheet. It'll be structured in rows in a completely different table. And it'll look something like this. So if we look at report 9991, you can see that that number occurs twice on this table. And that's because report 9991 has 2 offenses in it. And if there's a third offense, we don't have to add another offense column. We just add in another row. And we indicate that, hey, this also connects to report 9991. Then we're going to do the same thing with suspects or people. We'll have a report number that will relate this table back to our original table. And if we have 2 suspects, then we just simply put in that the report has, we just put in the report number twice on 2 different rows, and then we put each suspect information on its own row. These tables can then be connected to each other by that report number column. We can essentially tell how many offenses report 9991 has by relating this table to the table of offenses. And when we do that via what we call a join. We join these 2 tables on the report number field, 9991, and then we can write a query that will tell us information from both of these tables. This is why we call these databases relational databases, because all of the tables relate to each other. Database tables can have a couple different relationship types. One-to-one, this is where an object in one table can only connect to one object in another table. We don't deal with these super often in law enforcement, but they happen every now and then. So imagine if you had 2 tables, one contained people and one contained social security numbers. Well, that should really only be a one-to-one relationship, because every person should only have one social security number, and every social security number should only be connected to one person. Very often in law enforcement, we see one-to-many, and those would be like the examples that I was just discussing. You'll have a table of incidents or offense reports, maybe, and those can connect to tables of offenses, or they can connect to tables of people, and there can be multiple offenses in every report, and there can be multiple people in every report. So one report might connect to multiple offenses, one-to-many. Most database engineers will go very far out of their way to avoid many-to-many connections, because they become very difficult to work with. When multiple records in the first table can be associated with multiple records in the second table, things get a little wonky. And so we'll actually structure our data in police department databases to avoid doing this. And I'll explain how they do that here in just a second. So let's take an example where we've got a table of people and we want to connect them to a table of cars. So we have our person table over here, and every row contains things that can only occur exactly one time for a person. First name, a last name, a social security number. That person will probably also have a person ID, and that person ID may not be something that this person is ever aware of, but it's like a unique number that the system identifies that person with when they first go in. And then over here on the table on the right, we've got a table full of cars. And so again, every row represents something that can only occur one time for each car. Each car can only have one color, it can only be one year, only one make, only one model. And if we want to relate these 2 tables together, we could put in an owner ID column here that relates to the person ID column over in this person table. And so now we can connect people to the vehicles that they own. This works really well if only one person can own one vehicle and only one vehicle can be owned by one person. But this becomes a real problem if two people can own a vehicle. Now we're right back to our spreadsheet problem, right? We have to add a second column for like person 2, and then which column do you join on, and this gets really, really messy. This is going to turn into a many-to-many connection really quick, and we don't want that. So instead of structuring data this way, we'll often do something like this. We keep all of our people isolated over here in a table where every row contains one person, and every row contains things that can occur in that person exactly one time. And then over here on the right, we've still got our table of vehicles. Every row represents one vehicle. But then in between them, there'll be a table of what I call permutations. It's combinations of people and vehicles. And so if person number 1, 2, 3, 4, 5 and 2, 3, 4, 5, 6 can both own vehicle 1, 2, 3, 4, 5, that's no longer a problem because we can come over here and we can create one row that represents the first relationship. Owner ID 1, 2, 3, 4, 5 is connected to this vehicle ID. And then the second row represents the second relationship. Person 2, 3, 4, 5, 6 is also connected to vehicle ID 1, 2, 3, 4, 5. What this does is it creates two one-to-many connections as opposed to creating one many-to-many connection. And this is exactly how police departments will connect people to offenses. And when we're pulling NIBRS information specifically, the NIBRS handbook specifically talks about offense segments and victim segments. So you're going to have to be able to pull offense information, but you're also going to have to be able to pull victim information. So understanding why RMS structure is set up this way on the back end is going to be really important before we start writing queries. We're going to have two, as I mentioned, two challenges here. One is to pull offenses and one is to pull people related to offenses. And so we're going to wind up with an incident table, and then we're also going to have offense tables and probably people tables that we're going to have to figure out how to join. This is a look at the back end of Versaterm's RMS. So if anybody uses Versaterm or Versadex, I had to change the name of the people table. I think it's actually like dim people or something like that, and dim.events. But this is their actual schema. This is actually how they structure their data on the back end. They've got a clean table of people over here. So every row in this table is going to represent one person, and this table is populated with things that can only occur with people one time. You can only have one first name. You can only have one last name. You can only have one sex, things of that nature. Then over on the right, we've got this events table. And this is where your incident level information is for reports. And so every row on this table are things like date that the report occurred, location, unique event IDs, things like that. And then in between them is a table of combinations. So every row on this table is going to be one person and one event. And again, we do that because every event can be connected to more than one person, and every person can be connected to more than one event. So we keep these tables nice and clean, and we prevent many-to-many relationships by storing those relationships in one table, and we have a one-to-many connection between each of them. If you're not following this exactly just yet, we're about to get hands-on with it, and as we start to play with it, I think that this will become a little bit clearer. You may also wind up with slightly alternative RMS structures like this. So in this particular table, in this particular schema, you've got all of your relationships between people, events in one table. And then there's also a role field here. So if person number 1 in report number 1 is a victim, then this row will show person 1, event 1, role SK will indicate the victim. Over here, there is no role field anywhere because the roles are parsed out into different tables, but it's the same concept. People connect to all of these tables via one-to-many connection, and then events connect to these tables via one-to-many connection. Filtering out victims is just a little bit different. When we join these tables together, There's a couple different types of joins. In reality, we're only going to be focusing on one. We're only going to be focusing on one because I've only got 2 hours with you, but also it is the one that you're probably going to wind up using the most inside a law enforcement agency, and that is the inner join. And when we do an inner join, when we join these two tables together, we are going to produce via our SQL query a third table that is a combination of both of these. So you'll notice up here, these are our two source tables. We've got an incident table on the left. Every row represents one report or one incident, and it's got information in there that is unique to that incident. So like date, time, location. And then over here, we've got an offense table, and it relates to the report table via the report number, and it gives us the offense codes that occurred in that report. Now, when I join these together, I'm going to be able to produce a table that has columns from both of these tables, and that's really important because just getting a random list of offense codes without dates doesn't really help me if I want to know how many offenses occurred in the past year. And then getting an incident table without offense codes also doesn't really help me if I'm only interested in counting offenses or part A offenses or whatever. So I can join these two tables together and I can write a query that will produce a combination of both of them. I can pull in both the date and the time and the location as well as the offense code. The inner join makes it so that only rows where a value in one table matches a value in another table will be present in our new table. So for instance, let's just say that there was a report number 9994 in this table. Well, if there are no offenses connected to report number 9994 over here, then 9994 will not show up in our result. Same thing for offense codes. If there is this would be an error, but let's just say there was an offense code connected to report number 9999, but 9999 does not occur in the incident table, then that offense will not make it into our resulting query. So we're only going to get rows from both of these tables where a value and report number exists in both tables. Now there are other types of joins, but I don't necessarily think that we need to go super deep into that and potentially confusing. For the majority of the day, we're going to be working off of a query that looks something like this. So again, we've got reports over here, and we've got things, every row represents one report, and all of this is information that can only occur one time per report, like a report number, a date, the reporting officer, and then we're going to be joining that to a table of offenses via a key field that they have in common. So report number 123 is apparently connected to two offenses. One is a theft and one is an aggravated assault. So if you were to look up report 123 through the front end of your RMS, you should see two offenses there. Okay, so what does all of this have to do with SQL? Well, before you can actually start to write SQL, you have to understand how to navigate the back end of these RMS systems and how to join these tables together, or your SQL statement will be inaccurate. For those of you who have never touched a coding language before, SQL is probably the most simplistic coding language. It is also perhaps the most important. But you do talk to a whole bunch of rookies like me. That's like me over there on the left. Like SQL is really the only coding language I know. And so I just want to use it for everything. Once you get a little bit more advanced in the coding world and you start to learn Python and stuff, you start to see people who act like this. And they're like, well, it's not a real language. You should write actual code and blah, 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 blah. But when you actually start to meet the grand wizards of all of computer programming or whatever, they'll tell you that the actual Jedi Knights, they'll tell you that actually, whereas what we're going to learn today is very simple SQL does get incredibly complex and allows you to do some really advanced things very concisely as well. We're not going to get anywhere near that today. We're going to keep it very simple. But for an example of what SQL code kind of looks like, this right up here is a line of SQL. And basically what I'm saying is I have a table, maybe it's offenses, maybe it's incidents, whatever, and I want to select everything from it. So I want to pull every row and every column from this table out, and I want to put it somewhere like a visualization tool. So if you can wrap your mind around this little statement right here, select asterisk from table name, then you can wrap your head around what we're doing as we write SQL code. There are a whole lot of open source SQL writers. SQLite Studio is a favorite of mine because it's free, it's open source, it's very easy to use. Microsoft SQL Server is a pretty popular one. It allows you to do things like limit data, transform data, aggregate data. For those of you who would like to see what that kind of looks like, this is, and I include a link to this at the end of the presentation. This is w3schools.com. It's a little SQL writing game. And you can practice writing raw SQL here if you want. Basically, it shows us the database over here on the right, and we can see all the tables in that database. So let's just say we want to go to the orders table, and then we've got a SQL statement here, select all from orders. If we run that, it's going to give us the entire table. You can also limit it down. So maybe you only want to see orders where the employee ID equals 5. Now my table changes, and now all the rows here only show rows where the employee ID equals 5. You can also change it so that you don't pull in every column. You can pull in just specific columns. And so now I'm only showing the columns where, I'm only showing the customer ID column from this table where the employee ID equals 5. We're not going to play around with writing code raw. We're going to use what I call training wheels, something to make this a little bit easier. We use Microsoft Access. So why do we use Microsoft Access? It is easily accessible. It integrates with Microsoft Office. It's a very familiar interface, and there's an extensive user community. It allows you to just point and click and drag things as opposed to having to write out all of that stuff raw. There are a ton of functions in it. They work just like Excel formulas, and Twinkies, cockroaches, and Microsoft Access are the only 3 things that are ever going to survive nuclear war. You will find this everywhere. So if you're working inside an agency and you have an IT department that is a little difficult to deal with, chances are they're going to view Access as something that's pretty benign and harmless. You're going to have more chance of success getting to use this than just about anything else. Okay, so all of this starts with an ODBC connection. We're not going to actually set up an ODBC connection today because in order to do that, I would have to basically share out, I'd have to get all of your IP addresses, and I think that might be a little difficult. So I did, however, want to show a real quick example of what that kind of looks like to set one of these up. So is everyone seeing my screen again? I had to kind of switch it up a little bit what I was sharing in order to show this.
Yes, I see your screen.
Okay. So I've got an Azure database here, and if I wanted to set up a ODBC connection to it, it's actually pretty simple. So my server name is right here, and if you're connecting to a police department RMS, your IT department is going to be the ones that have all of this information. But setting up that ODBC is super simple. If you're using Windows, you just type in ODBC. It brings up this little ODBC connection wizard. You can hit add. You have to pick your driver. This is a SQL server, so I'm going to pick SQL server. It's going to ask me to name it and describe it, and then it's going to say, hey, where is your server located? So I'm going to give it the location. I'm going to tell it that I want to log in with a username and password. My username is journadmin. I'm going to type in my password. Oh no, come back. There we go. There we go. And now we're connected successfully to the backend. That's all it takes. It takes about 10 seconds. I know that a lot of places struggle to get IT to cooperate and give you that information, but the actual lift of putting in an ODBC connection is very simple. If I then want to fire up Access and connect to the back end of that database, I can open up a blank Access database. No. I can go to external data, new data source, from other source, ODBC connection. I'm going to create a linked table. It's going to ask me which ODBC that I want to use. I can pick one from up in here. and then it'll show me all of the backend tables and I can make a query. What we're going to do today is going to be a little bit different than that, but I did just want to show that process very quickly. I've found in my experience that when you're working with a IT department that may not necessarily want to cooperate with you, the magic phrase is read only. So with an ODBC connection, you could go in and start editing reports, and they don't want you to do that. All you as the analyst need is the ability to extract that data out and put it somewhere so you can analyze it. So therefore, all you need is read-only connections. Okay. So at this point, I'll just ask if there are any questions before we dive into the hands-on part of this. I'll check the chat real quick. Doesn't seem to be any. So if everyone wants to you should have those files from the Google Drive downloaded. And inside that drive, you're going to see a couple of things. The first one is this ERD diagram. This is from Spillman. This is a document that most RMS providers should be able to give you. And this is going to show you how to actually put all of these joins together. I know that this looks super duper intimidating. What might be a little bit easier to read is something like this. This is a code book for an RMS called Spillman. And so all of these are the names of tables on the back end, and all of these rows below there are the columns that you should be able to see. And then this is a description of what type of information that column will contain. This ref index column tells you what other tables this column should be able to connect you to. I don't necessarily want to spend a lot of time on this. I just wanted to throw this out there for the purpose of example. This documentation should be available for whatever RMS you're dealing with. But once you've got those files downloaded, what we're really interested in is this journ access database. But we're not going to open it up. Instead, what we're going to do is we're going to create a blank Microsoft Access database. So if you just open up a blank Access database and name it whatever you would like, we're going to go through the same process you just saw me going through to connect to the database, but now instead of doing an ODBC database, we're just going to connect to that Access database. So to do that, I'm going to go to New Data Source, from Database, and choose Access. When you connect to a database, you have two options. You can import tables, or you can link to them. I almost always encourage you to link to them. When you import tables, you're basically going to make a copy of that table and pull it in to your Access database. When you make a link to it, you simply keep a link open between the new Access database you're creating and the back end of the RMS database you're querying. So it allows you to write a query. And if we run that query again tomorrow, it's always going to be pulling in the most recent data versus if you make a copy, you're only going to have what you had whenever we import it, and we don't want that. So I'm going to link to the data source by creating a link table. I'm going to browse, and then if you browse over to that file that you downloaded, and then the Access database called journ, and hit open, and OK. When you do that, it's going to bring in this little window here. And what this is showing me is all of the tables that are contained inside that Access database. Now, when you do this in a real RMS system for the first time, you're going to see, I don't know, as many as 2,000 tables. The vast majority of them contain no information that you're actually interested in. But there will be an instance table, and there will be an offenses table. If you're using Spillman, it's called, the incident table is called LW main, and the offense table is called LW offs. I've seen them call a whole bunch of other different things. You may have to dive around a little bit or consult one of those resources that I was showing you earlier to figure out the name of the table. But I've made this really easy for you. We're going to be working with 4 tables, all 4 of which we've already talked about conceptually. And to select more than one, if you just hold Shift as you click, you can click on all 4 of them and hit OK. Now, when you do that, you now have a window open to that other database so that we can write queries on the most up-to-date data. And over here on the left, you'll see that it adds table icons. If you're not seeing this on the left, you might have this window closed. You can open it up. Additionally, if you are not seeing it, you might want to hit this little drop down and make sure that you've got all access objects selected. And from here, you can double click on these tables and actually open up and see the data that's inside. So here's our incidence table, here's our offense table. And so these are going to follow the structure that I was talking about earlier. We've got a column called report number and incidents. We've also got a column called offense number and offenses, but we've also got a report number column here. So if we sort this, smallest to largest, what this is telling me is that, okay, report number 3 has 2 offenses connected to it. One was a 13A and one was a 270. And we've also got person events. This is that table of combinations of people and events. And this is our master person table. Every row is just one person. So you're welcome to click on these, look and see what data is underneath there. To actually start writing a query, once you've got those tables in, we're going to go up to create and query design. So the first thing you have to do is decide what table you want to query. And so because I know we're going to start with something simple, we're going to start with pulling offense segments. The first thing I'm going to do is pull in my incidence table and pull in my offense table. Now again, remember, I'm doing this because chances are, in order for me to analyze this data and look at trends over time and things like that, I'm going to need information like the date that it occurred, and I'm going to need the NIBRS code telling me what type of offense it was. And those two things don't occur in the same table. I've got date over here in incidents, and I've got the offense type over here in offenses. So I'm going to have to perform a join. And this is a really easy example because there's really only one field that connects these two together, and that is report number. So the first thing I have to do is perform a join. To do that is really easy. I'm going to come over here to my incidence table. I'm going to click and I'm going to hold report number and I'm going to drag it over to the offense table where it also says report number. And when you do this, you want to make sure that that line is going from your report number field to your report number field. You can also double click on this and it brings up those properties and you can make sure that the right column name and the left column name are proper. Additionally, I'll point out that this number 1 option is always going to be your inner join. So we talked earlier about the difference between inner joins and outer joins. An inner join is only going to produce a query where the values occur in both tables. And that's what we want here. I'm going to click OK. So now I can start adding columns to my query. And you can think of this section down here below that kind of looks like a spreadsheet a little bit as the new table that we're going to create via the SQL query. And we can add columns to this new table by clicking and dragging them down there or just double clicking. So the first column that I'm definitely going to want is report number. So if I double click on report number, it adds it to the query down here. And I'm also definitely going to need date. And maybe I'll need something like zone. I don't know. And then maybe offense type and closure type. And so you'll notice that as I'm double clicking on these fields are getting added to the bottom down here. So at this point, I've actually got a SQL query written. As I'm adding things to this bottom field down here, and as I'm adding criteria, it's actually writing SQL for me. And you can see that if you come up here to the query tab and right click and go to SQL view, you can see a whole bunch of text here that looks very much like that SQL statement that I was just writing raw earlier. It's just now it's writing it for me as I click and drag things around in this query view. And if you right click on this and go back to design view, now we have our nice clean interface again. All right, so let's add some other stuff. Why not? We'll add in, victim injury. Maybe we'll add in some address stuff. If you're mapping, you'll definitely want that long. All right, so we've got a bunch of columns added here. And if we want to run this, you'll notice up here on the top left, we've got select chosen. That means that this is a select query. We're not going to get too deep into the different types of queries, but for right now, select is just fine. And if I click run, it's going to show me my new table here. And you can see I've got some information from the incident table, like the date, the zone that it occurred. And I've also got some information from the offense table here. One thing that I like to do is to, at this point, look up some of these report numbers and make sure that I've got all of the offenses there. So you can sort this by report number, and you can look up 480 and make sure through the front end that 480 includes a 120, which I think is a robbery or something like that. If you right click on this tab again, you can go back to design view and you can keep working on your query. Now, Microsoft Access has a really robust ability to add criteria, and that is to filter things down. So if you look at this incident data, we're looking at stuff that has occurred over the past, I don't know, 3 years. Maybe we don't want that much data. Maybe we want to limit the number of rows. Well, you can add in criteria here to each of these fields to restrict down how much data you're looking at. So whenever I run this query as is, and I go to the very last row, you can see that this query is pulling 30,000 rows of data. Well, let's limit that down by using a formula. You can filter dates a couple of different ways in Microsoft Access. The way that I would encourage you to do it is to always use a relative date. Meaning, if I always want this query to pull 365 days of data, I don't want to type in September 27th through 2023 through September 27th, 2024 in here, because then I'm going to have to come in and change that query every day. So instead, I'm going to use greater than or equal to now in all caps, open a parentheses, close a parentheses, minus 365. This is going to pull, instead of the entire body of data, just 1 year. Again, that's greater than or equal to now, open, close, minus 365. Now, if we run this and click over to the end, you can see we're only pulling 9,335 rows of data. You can filter similarly on things like text. So maybe you're working in a city that shares their RMS across multiple municipalities, and you only want to pull stuff that occurs in one jurisdiction. Well, the city field is text, so this is all Georgia, so maybe I only want to pull stuff that occurs in Atlanta. You'll notice that when I type Atlanta in and whenever I click out, it automatically puts Atlanta in quotes. And when we run this again, now you can see all of our cities are just Atlanta, and we're only pulling 4,000. You can also use or and operators here. So you can type in or Augusta or whatever and make that a little bit more sophisticated. And now we're pulling 500 additional rows. And at any point, you can also click back and forth and look at the SQL view and how this is changing. This is one way that I learned how to write SQL, was to do it first in Microsoft Access, use the interface, and then just look at the text and see how this is changing as I add new stuff and go along. You can also set this up to be undefined. So say for a second, you had a whole bunch of people working in your office, and they all need a way to pull data. But they're all going to have different cities and different date ranges that they're looking at. You can put in what we call placeholder values. And placeholder values are undefined values. So every time this query runs, it's going to ask you to define it. So for instance, maybe we want to write a query for everyone to use in our office that always looks back 365 days. But you know, analysts from different cities might want to filter down to different jurisdictions. I'm going to come here to this criteria under city, and I'm just going to type in with a square bracket input city name. Now what that does is it tells it to refer to a variable that is totally undefined. So when this runs, it's going to ask me to input a city name, and I can type in Atlanta or Augusta or whatever. Well, maybe whenever the next person comes in and runs this, they're only interested in things that happen in Valdosta. So they can type in Valdosta, and now they're only getting data for Valdosta. Maybe you want to change up your date range. And every time you run this query, you might have different date ranges. You can use a between function between date 1 and date 2. So now I've changed this criteria up a little bit, but I've done basically the same thing. I've given it 2 dates that are undefined. So now when this runs, it's going to ask me for date 1, and I have to type in 2023, 2024, Atlanta. So now I'm going to get everything from 1/1 of 2023 through 1/1 of 2024 for just the city of Atlanta. So you have a whole bunch of different criteria you can play with here. Whenever you're done, you can save this. I'm going to just call this journ query 1. And you'll notice that it becomes a new object over here. For getting data out of Access and into something a little bit more usable, like Excel, you have 2 options. I'm going to change this to a make table query. When you do that, it's going to say, all right, when this query runs, it's going to make a new table. What do you want that table to be called? And I'm just going to call this new table journ table 1. I'm going to save it in the current database, and I'm going to click OK. So now when this runs, again, it's going to ask me for all of my information that I want to put inside this query. It's going to tell me how many rows there are, and now it creates a new table. Getting this data out, I've got a couple different ways I can do it. I can right-click on this and I can hit export, and it will let you choose how you want to export it. I like to just embed it in an Excel workbook. So I'll open up just a blank Excel. Here we go. And now I can actually connect to this table inside the Access database. And to do that, you just go over to Data, Get Data from Database, from Microsoft Access database. You navigate over to your Access database that contains this table that you want to connect. Here we go. And we've got all of our tables there. I might need to redo that real quick. I'm going to save this. Might be connecting to the wrong database somewhere. But once your table is inside Microsoft Access, you can then connect to it. Oh, because I'm connecting to the wrong thing. Of course, I didn't save it as a name, but I'm going to remember. Whatever. Once you've got a table made up inside your database, you can connect to it via Microsoft Access. I'll just pull in my incidence table for the sake of example and hit load. For those of you who are familiar with Power Query, you can trigger Power Query at this point by hitting Transform Data. There we go. And now every time that SQL query runs, it's going to update that table. I can come into Excel and I can hit refresh, and it will pull in the most up-to-date data after the SQL query is run. So that's one way to do it. You can do it manually by just simply exporting it in Access, or you can set up an Excel file that connects to that table. And now every time I want to refresh, I rerun the SQL. I just come in here and hit refresh all, and it brings in the most recent stuff. And then from here, you can connect it to Arc Pro, Power BI. You can build formulas in here that read off this table of data and automate the creation of analytic products. Anything you might want to do. All right, so I know that we're really short on time, and I also know that I just threw an absolute ton of information at everybody today. So I do want to pause for a minute and just ask if there are any questions. I want to see if I can get my access out of here. So there it is. Churn 1 is what I called it. So one of the questions is, the schema PDF provided the real table names, column names, and schema to access real NIBRS data so long as there's an OUC connection established. Yes, for Spillman RMS only. And the schema that I showed you in the presentation was for Versaturn. Every RMS vendor is going to have their own schema, their own table names, their own column names. So depending on who you're working with, those are all going to be a little bit different. You can attempt to contact the RMS vendor, and depending on who it is and the relationship they have with the agency, they may or may not be receptive to that. I'll be real honest with you. A majority of the time that I go into a new police department and I'm working with an RMS that I'm unfamiliar with, I basically have to spend a significant amount of time going through all of the tables on the back end to try to find what I think contains offense information. But typically there's also some naming schema that hints it away, like typically the word offense, or typically the word incident or report or event or something like that in a table name gives away that it's something that I might be interested in. But yeah, if you're using a Spillman Flex or I think Central Squared has a very similar schema, then yeah, those documents will point you in the right direction. Any other questions?
Okay, I think while we're waiting like a couple of minutes for question, I was wondering if everyone could please, I would appreciate if you guys give your feedback. So in the coming webinars, we do our best to reflect on what you want. And also like this webinar was provided by SJS Grant. So we would appreciate it if you fill it out so we could kind of like put it in our report. That would be really awesome.
And for our next get together next week, that feedback is really important. I can spend 100% of the time talking about SQL functions and pulling individual segments and adding filters and stuff like that. We could also talk a little bit about actually once your SQL is done and you've pulled out your table of information that you're interested in, how can you use Excel or Power BI or something like that to automate pattern and trend analysis and create reports and things like that. I do want to just very quickly give a couple shout outs here. So if you want to look at all the different ways that you can add query criteria in MS Access, you can hit this little QR code. It'll take you to the Microsoft page, and it'll show you how to add date filters, and text filters, and things like that. I do have some information in here about data cleaning. We didn't really get there this week, but we'll pick up there next week. And then at the very end of this presentation, here's a link to w3schools.com. That's the little SQL emulator that you saw me playing with. You're more than welcome to come in here and play around with that. And then also bdanalyticsllc.com. That's my personal website, and I put up all sorts of instructional stuff here. So if you were really taking to SQL and you want to learn how to do things like paginated reports in Access, or how to automate Excels once you've got that output, I've got a webinar on there that a partner Amanda put together as well. So this learning tab contains a lot of really good stuff that builds on what we've talked about today. And I will put a link to this Canva presentation inside our chat so that everybody can access that. There you go. Canva link is in there. And that link works forever. So as I add stuff to it, you'll be able to see all of the new additions and things like that. So check back frequently. I'll just update that for next week so you guys can see what I'm working on in the meantime. And if there are no other questions, I will just wish everybody a really great weekend, and we will see you next week.
Great. And thank you everyone for joining, and thank you, Charlie, for the instruction, and have a great weekend, everyone.
Thank you.